Alright, so deductive reasoning. Deductive reasoning is the process of reasoning logically and drawing a conclusion from given facts and statements. So, you know who Sherlock Holmes is, right? Yeah. Sherlock Holmes used deductive reasoning in figuring things out. I think he told Watson one time, data, data, data. I cannot make bricks without clay. So this is his form of reasoning that he used. So what is it? We've got two things we're going to talk about, the law of detachment and then the law of syllogism, and learn how to use these things. So they apply when we're given conditional statements. So a conditional statement is if P then Q, correct? So if the hypothesis is true, then the conclusion is true. So that's why we have that caveat that whenever we're doing logic and proofs, that our statements can have to be vacuously true. It's like absolutely true or absolutely false. There is no gray area in them. So this is how we symbolize the arguments that we're going to do. So if you're given a statement, P implies Q, and then somebody tells you, well, P is true, we've got this, and then this. Anybody know what this little symbol right here means? Alright, I like to think of it as like the Predator reticle. Alright, what the Predator aimed with. Nobody seen the Predator? Yeah. Okay, so you know what I'm talking about. So this means therefore. So P implies Q. I tell you that P is true, so you can say therefore Q. So that's the order that we have to go in. If I tell you that, give you a statement P is implying Q, and then I tell you that P is true, then you can go ahead and derive that Q, the conclusion is true as well. So here's a couple of examples. If Mark saves $30, then he can buy a new video game. All right, so here's the P, everything after the word if and before then. So P implies Q. Then he can buy a new video game. So here I'm telling you that Mark saved $30. So P is true. So we can conclude that Mark can buy a new video game. Okay, so if a quadrilateral is a rhombus, then it's also a parallelogram. Here's the P, and then it implies Q. So quadrilateral ABCD is a rhombus. All right, so they're telling you that this part is true. So this is P. So we can conclude that quadrilateral ABCD is a parallelogram. All right, so is this making sense? Not too awful bad. So make sure that you name these things and see where your argument is going, okay? So if you are 18 years old, then you can register to vote. So P implies Q. So this says Olivia is not 18 years old. So this is telling me not P. Can I conclude anything from that at all? Right. So it has to follow this order here. P implies Q, P, therefore Q. You can't derive anything from that particular statement. No conclusion. Remember, it has to go in that order. P implies Q. I tell you P is true, so you could conclude this. We said not P. I don't know what this is going to entail, right? So not P, I have no idea what it's trying to imply. Because saying that Olivia is not 18 years old, she could still vote, right? She could be 35 and still be able to vote. So number 4, if the sum of the measures of two angles is 90, then they are complementary. So P implies Q. So we say that the measure of angle J and the measure of angle K is 32 degrees. So we're given what two angles are measured. So does that sum up to 90 degrees? Yeah. So if these two sum up to 90 degrees, that's true, so we can call them complementary angles. So angle J and angle K are complementary. Alright, so P implies Q. And then Sarah purchased a prom ticket. Is that my hypothesis or my conclusion? That's your conclusion, right? Purchased a ticket. She purchased a prom ticket. So P implies Q. Q, therefore, nothing. Right? We can't derive anything from that. We can assume all day that she's probably going to attend the prom, but we're going from Q to P with this particular problem. So this is no valid conclusion. So she purchased a prom ticket. She could be giving it to somebody else, right? That doesn't necessarily mean that she's going to go. Did everybody have this? Okay. So, the law of syllogism. This is really close to the transitive property that we've got in algebra. A equals B, B equals C, then A is equal to C. Right? That's your transitive property. So your law of syllogism says that from two conditional statements in which the conclusion of the first is the hypothesis of the second statement. So for you to be able to use the law of syllogism and the law of detachment, you have to have them in these forms before you can say that they're true or not. So your first one is P implies Q. You have to have a statement that says P implies Q. Your next statement that you're given has to be Q implies R. See, the conclusion of the first statement is the hypothesis of the second statement. So, therefore, P implies R. This Q is connecting both of these conditional statements. So how we feel about that? Thumbs up? All right, not too bad. We're not getting on shaky ground, are we? Okay. So let's try to use this thing. If it's Saturday, then Jake has a baseball tournament. So P implies Q. If it's Saturday, baseball tournament. So let's make sure that the hypothesis of the second statement is the conclusion here. So if Jake has a baseball tournament, all right, so those are the same, right? So Q implies, then he will need to pack his lunch. P. P implies Q, Q implies P. So what can we conclude from that? Or, sorry, Q implies R. Right. If it's Saturday, then Jake will need to pack his lunch. All right. So I'm going to let you all work on 7 and 8 here, but I want to show you an example of what one looks like that we can't use the law of syllogism with. So on number 9, if it's sunny this weekend, that's my hypothesis. And then we'll say implies Q. All right. So my conclusion of my first statement is you will go boating. So here, if it's sunny this weekend, well, that's the hypothesis of my first statement. So we're saying P implies, and then a completely new statement, you will wear shorts. So we'll call it R. So P implies Q, P implies R. These two have to be the same. Your hypothesis and your conclusion and your hypothesis have to match up. So there is no valid conclusion here. All right.